Okay, so this is also quadratic formula that is used to solve for a quadratic equation. Eventually, this is much easier and then also can solve every quadratic equation that you see. Now, you go through this to be able to solve for any quadratic equation. We said that that equation should be written in the form ax squared plus bx plus c equals 0. So this is what we've already established. If I am able to do this, then how do I go about the equation? And so if I have, say, this there, then I'm going to solve using this formula, which says that if I'm solving for the values of x, then always the values of x are going to be minus b plus or minus the square root of b squared minus 4ac over 2a. Okay, now this is just the formula. This is just the means by which I will get my x easily. And so, should I get this? Should I have this formula written? What happens is that I just plug in the values to make sure that everything is okay. Now, when you get this, we have what we call the discriminant. And so, in this case, when we say discriminant means that under the square root, you have b squared minus 4ac. Now, that describes the nature of the roots and also suggests possible formulas that can be used to solve the equation. And so this is just a means to test which method is always very good to solve for this equation, because we know that for factoring method cannot solve equations that have solutions of complex numbers or have complex solutions. And so if you test for this, it gives you an idea of which method is very good too. And it also tells you the nature of the roots of the equation. So for instance, if I have my discriminant, if I solve for every equation and I have my discriminant being greater than 0, then it means that, so if I have my discriminant greater than 0, it means that I have two real roots. So it means that this is very good. I can use any method to solve because I'm getting real numbers and it's making it very easy. Now, if I solve the equation and I have my discriminant, which is equal to 0, then I'm having two roots two repeated roots. These roots are also real. Okay, so how do we mean by two repeated roots? How do we mean by two repeated roots? So, for instance, if I have a question in the form of x squared minus 4. Okay, so let's work on this, then we'll come back to some examples. Okay, now we have this equation as if my discriminant is less than 0, then I'm expected to get something that is not real, but I have complex roots. So by complex roots, I mean those imaginary roots that has the I. Okay. Now, let's go back to work on this. If I have this first equation on the board, so I have x squared minus 4x plus 3, and I want to just test and see this. I want to test this and see the nature of roots and also describe it. So I test using a formula. B squared minus 4ac. Okay. Now I have equation x squared minus 4x plus 3 equals 0. So this is the equation I have. Now to be able to go through this successfully, now I know that for this, the coefficient of x squared is always a, and in this situation, or in this case, the coefficient of x squared is 1. But for the coefficient of b is always this, and so in this case it's -4, and then c is 3. So I plug in a equals 1, b equals -4, c equals 3. So what do I have? If I'm looking for a discriminant, I have -4 squared minus 4 multiplying 1 and multiplying 3. So my discriminant is -4 squared, 16 minus 12, and discriminant is -4, which is greater than 0. And so once I establish this, then it means that I'm going to have my solution having 2 real roots. And so if I'm supposed to describe the nature of roots of this, then it has what? 2 real roots. So this is the solution for my discriminants, and the description is it has 2 real roots. Sounds good? Right. Okay. The next equation that I want to consider is x squared minus 6x plus 9 equals 0. And so if I have this, now a equals 1, b equals -6, and c equals 9. So once again, plug in. I have b squared minus 4ac. Okay, so I keep on plugging in the values. So I have -36, -6 squared minus 4, 1, 9. So I have 36 minus 36, and this equals 0. Now, because the discriminant equals 0, this implies that I have 2 repeated real roots. Now, so by repeated real roots, we mean that you should have the same root twice, because don't forget that we said that quadratic equations have two parts of solution. So once we go through and solve this using the formula, you will see that we'll get just only one, but that one repeats itself. Okay, so we'll do that very soon. It sounds good. So just test for the discriminants and know which part of the equation you're dealing with. But then if the equation just says that, or if the question just says that solve the quadratic equation, it doesn't mean you don't have to do all these things. If they want you to test for the nature of solve for the discriminant, the question will just say solve for the discriminants. Maybe A and B, or I will just say describe the nature of roots. Then another question, C, would just go ahead and say solve the equation or solve the quadratic equation. So it depends on how it is. You don't have to be going through all this when you are solving for quadratic equations. That's what I just mean. I mean that if you're going through solve quadratic equation, you don't have to go through all these things. I'm going through all these things because this is also part, and in some of the equations, I think one of your homeworks says that you solve for the discriminants of the equation and also explain or tell us the nature of roots. And so that's it. If that is the question, that is the way you are supposed to go about it. Nothing more, nothing less. Thank you. Okay, now let's consider the last equation, which is I have x squared plus x. This time around, I want to change this to this. Now, don't forget that we said that at every point in time, if you were solving with squares, method of squares, you would have left it here. But because you are not solving with method of squares, always make sure that it follows the standard. And so the standard says that you have ax squared plus bx plus c equals 0. It doesn't follow the standard. Okay, so to follow the standard, I have x squared plus x plus 1 equals 0. So this is the standard we're talking about. Okay, now, to be able to test for the discriminants, it says that I need b squared minus 4ac. And so from this, b equals 1. So I have a equals 1, b equals 1, c equals 1. So just plug in these values. And so I have 1 squared minus 4, 1 times 1. And I have 1 minus 4, which gives me -3. So my discriminant is -3. Now, once I get this as my discriminant, it says that, how do I explain this? I explain it by saying that because this is -3, which is less than 0, then the nature of this root is 2 complex roots, where I get imaginary numbers in that order. Yeah, so this is it. If you are asked to go through how you will solve for nature of roots or solve for the discriminants and determine the root or explain the roots, this is how we're expected to go. Okay. Now we come back to how we can solve the entire quadratic equation using quadratic formula. So the first thing says that make sure that everything looks like this. That is, you have ax squared plus bx plus c equals 0. Now, if you're able to get this, now get the values of x. So let's consider the first equation. In the first equation, our x was greater than 0, and so we expected to get 2 real roots. Okay, so if you solve such equations and you get like an imaginary number, it gives you an idea that what you did wasn't right, or there was something wrong with the solution. And so let's have it. So we have x squared minus 4x plus 3 equals 0. If I have this, great, I'm good to go. Now, I'm solving with this, and so my a equals, from this 1, b equals -4, c equals 3. Just plug in these values here. And so I have x equals versus minus 4, okay, plus or minus root of, so I'm just bringing this because the b part is -4, and this one is also -b, and so if you plug in -4, you distribute this negative to -4. Okay, and so where this one says that I have -4 squared minus 4 minus 4, which is the b, and then multiplying a, which is 1. Now, most of us make mistake by saying that instead of, now this 2a is for everything here on the right side, not for just the one under the root. Some of us make mistake by just putting it just here. It's wrong. You always have to show that it's for everything on the right side. Everything. Okay, so 2 times 1, which is the a. Now we go through this. -1 times -4, 4 plus or minus square root of 16 plus over 2. Okay, so at this point I have x is equal to x plus or minus square root of, okay, let me come down so that it becomes so visible. Let me clean this. So this is 16, x equals 4 plus or minus 2, x equals 4 plus or minus square root of 32 over 2. Okay, so when you get to this side, because you have this, it's always good to go again. Now, how do I go? Because I know that x equals 4 plus or minus square root of, now 16, I have square root of 16 times square root of 2. Over 2. Okay, so if I want, I will just say that because this belongs to the 2, I will say that 4 divided by 2, or 4 over 2, plus or minus, that's square root of 16, s 4, so I have 4 divided by 2 times root 2. And so I have this 2, so I have my x equals 2 plus or minus 2 root 2 Yeah. So this becomes my final answer. X equals 2 plus 2 root 2, and then my second part of the x is 2 minus 2 also root 2. Sounds very simple. Very, very, very simple. I have these two. If you want to take the decimal, it's okay, but once you get to the side, there's no need going forward again. It's okay. So if you get decimals for this, that's when, because most of us, when we get to the side, we decide to jump, and it makes it very difficult working on those things. And so please, you have to follow systematically and you'll be fine. Okay, at this point, let's take the first example that we did with complex numbers, completing squares, and solve. We see that that is very simple because that one we had numbers that were very friendly. So let's go by that. We had 2x squared minus 4x minus 6 equals 0. Okay, so if we have this, the first thing is it like this? Yes, it is. And so our A equals 2, B equals -4, C equals -6. Okay, and so if we're looking for x, solving for x, then our x is, we have minus -4 plus or minus the square root of -4 squared minus 4 times 2 times -6 over 2 times 2. Don't forget I said that this is always inclusive with everything. This is part of everything. And so don't leave it here and think you are good. It's for everything on the right side. So x equals 4, that's -1 times -4 gives you 4, plus or minus square root of 16, -4 times 2, so -4 times -6 gives you 24. Okay? Yeah? 24 times 2, 48. And so plus 48 over 4. Okay, so if I have this, then I have x equals 4 plus or minus square root of 16 plus 48. And that is 64. Over 4. Okay. Okay, so x equals 4 plus or minus root of 64 is 8 over 4. Once again, if you think that you're good, because this is for both sides, you can just say that your 4 is, you have 4 divided by 4. So x equals 1 plus or minus 2, and your first x value is 1 plus 2 equals 3. Your second x value, 1 minus 2 equals minus 1. So if you can check from the first video, which was completing squares, you realize that these were the solutions that we have. X1 equals 3, x2 equals minus 1. Sounds good? So whatever we're doing is that you try to make sure that you follow everything and you'll be fine. Okay. You'll be fine. Okay. So now let's speak about 2 more examples. Then we can say that we're good. So to be able to solve for x minus b plus or minus square root of b squared minus 4ac over 2a. Okay, so let's try this example that says that it has 2 roots repeating itself, or 1 equal repeating root. And so let's have it. We have x squared minus 6x plus 9 equals 0. Once again, our a equals 1, b equals negative 6, c equals 9. And so we plug in. So to be able to find our x, we have negative 6, negative 1. We can go ahead and say this is 6 plus or minus square root of b squared. So what's our b? Negative 6 squared minus 4. Our a is 1 and our c is 9 over 2. Okay, so at this point, if you like, you can decide to split the denominator for both expressions. So I can have x equals 6 over 2 plus or minus square root of 36 minus over 2. Okay, so realize that I have x equals 3 plus or minus 0. And so now you can see that the x value is always equal, is only equal to 3 at this point, and not, we don't have any other. But because this is there, we say that this is twice, because it's a quadratic equation. You're supposed to find, or you're supposed to get 2 different roots. And so anytime you solve to get this, and you're sure that the root is equal to 0, it's giving you this, but this is 2 times. And so to be able to write this, you say that, and to get the full credit, you say that x is equal to 3 twice. That means x is equal to 3 and x is equal to 3. In other words, you can just say x1 equals 3, x2 equals 3. It's the same as writing 3 twice. It means that because you are solving for a quadratic equation, you need 2 parts of the equations. I believe by now we have gone through so many, and I think you guys are good to go. Now let's finish with the last part of the equation, then we say bye-bye for the day. Okay, so now our last equation set is x squared plus x plus 1 equals 0. And so our a equals 1, b equals 1, c equals 1. Okay, now I decide to plug in these values and see what happens. And so x equals -1 plus or minus square root of 1 squared minus 4 times 1, and I'm good to go, over 2. That's it. Now, what's the next step? Says that I have x equals -1 over 2 plus or minus square root of, don't forget I said that if you think that splitting it is okay for you, you may decide to split it. But if you are not splitting, then it means that this denominator affects the whole expression on the right side of the equation. And so this is it. At this point, I decide to split. So this -1 has its own denominator, which is 2, and the one in the radical sign also have another denominator, which is 2. So I have -1, 1 minus 4, I have -3. Okay, now how did we say we solve this? To be able to solve this, I have -1 over 2 plus or minus. And to be able to solve for this, I have 3 times -1, and my x values are -half plus or minus √3i. And so if I'm looking for the two parts of the equation, my x1 is equal to -half plus √3i. That's the first part of the equation. The second part of the equation is -half minus √3i. So you recall that this is very easy and makes it very simple. So once again, I think you guys are good. If you have any question, don't hesitate to also reach out to me so I can explain further to you. Thank you. Let me give you this. So solve this one. We did it during the video of completing squares. So x squared plus 6x plus 5 equals 0. So if you finish, you compare your answers to that of the first one that we did in the first video of completing squares. So this is it, x squared plus 6x plus 5 equals 0. Finally, I want to give you this to try your hands on. So first, you have to determine the nature of the roots. So you determine the nature of the roots. So you solve for the denominator, the discriminant, which is b squared minus 4ac. So you solve for discriminants of this equation. So I. Feel free to pause the video and write it. You can zoom it up and write it. Then you solve for the discriminants, and when you finish, you tell us, you determine the nature of the roots. So to be able to determine the nature of the roots, we say that we solve for the discriminant. If it is greater than 0, you have 2 real roots. If it is equal to 0, you have real roots, but that real root is only 1. You have only one part of the equation. So don't forget I said that if you have x equals 3, then it means that x is equal to 3 twice if you are solving for the quadratic equation. But if you want to determine the nature of the roots, then you say that this is having only one real root, or it says that one repeated real root, it's there. Then when you have a situation where you have x is less than, or your discriminant is less than 0, then it means that you're having an imaginary number or a complex root. And so you go through this. When you finish, you can just decide to solve this equation using the quadratic formula, because the more you work, the more you become conversant with, and the more you become so good at it. So I would employ you to, after going through solving for the root and determine the nature, you also have to solve for this equation using the quadratic formula. And the last thing that I want you to do is that you also have to solve the quadratic equations. So these are quadratic equations that I would love you to solve. Don't forget that we did this in the first video that was completing squares, and we also did this. And so when you finish, you compare your answers. We did part of this also. So once you finish, you could just compare your answers and make sure that everything is okay. On this note, I will say that thank you for watching, and I believe that you guys are going to be fine. Don't forget that we're going to use these two methods for our two quizzes. So our second quiz, which comes off on Tuesday. Until we meet, stay blessed and have a fruitful weekend. Thank you.